Good morning, everyone. Before we start our discussion, I want you to look at these pictures first. What can you observe? Okay, one Sunday afternoon, my sisters and I decided to bake a cake. In baking cakes, we need these main ingredients. We need 3 cups of flour plus 4 eggs in order to make one cake. However, we only have 6 eggs on the fridge. So, we decided to use 2 eggs on the first cake and 4 eggs on the other one. So, as we can see, the first cake doesn't look good. It didn't rise and it sank on the middle part, while the second one looks fluffy. It looks good. It looks almost perfect. So we see, if we want to have a desirable outcome, if we want to have a successful outcome, or if we want to be successful in whatever we do, we should remember 2 things. First, we need to know the right ingredients. And second, we should follow the right proportion or the right amount of that ingredients. The same thing with your academic journey. So, first year pa lang kayo. So, in order for you to be successful, in order for you to become chemical engineer someday, you should know the right ingredients for you to achieve that goal. So, what are these ingredients? So, it's for you to find out. So, this has something to do with our topic for today. So, do you have any idea now on what will be our first topic in general chemistry? So, our first topic will be stoichiometry. So, I know now we are all familiar with this term. Hindi na ito bago since we have encountered this during our senior high school days. Stoichiometry. So, this will be the flow of our discussion. We will be discussing the fundamentals of stoichiometry. Second, the limiting and excess reactant, and lastly, the theoretical and percentage yield. For our objectives, after this Unit 1, you should be able to describe the relationship between mole ratio and the coefficients present in a chemical reaction, construct mole or mass ratios for a reaction in order to calculate the amount of reactant needed or amount of product, and lastly, explain the concept of limiting and excess reactant. Okay, so what is stoichiometry? Stoichiometry comes from the Greek word stoichion, which means element, and metron, which means to measure. So by definition, stoichiometry is the quantitative study of reactants and products in a chemical reaction. This is the portion of chemistry that deals with the quantitative relationship between reactant and product. Meaning to say, we can be able to predict or calculate the amount of product that we can be able to produce given a certain amount of reactant. In stoichiometric calculation, the most common method that we use is the mole method. So, what is this mole method? Pero first, let us discuss what is mole. Ano nga ba ang mole? Mole, when we say mole, it is an SI unit of amount of substance. So, this is the amount of substance. Ibig sabihin nito, kapag sinabi natin 1 mole, it contains exactly 6.022 times 10 raised to 23 elementary entities, or 6.022 times 10 raised to 23 particles or atoms. So, mole method, in this method, the stoichiometric coefficients in a chemical equation can be interpreted as the number of moles of each substances. Let's say, for example, let's take a look at this example, at this reaction. If we have 2 molecules of hydrogen plus 1 molecule of oxygen, we can be able to have 2 molecules of water. So with this coefficient here, 2, 1, and 2 respectively, is called the number of molecules. These are the number of molecules, while the subscript here is the number of atoms. So we will be discussing later on kung ano ang difference ng molecules and atoms. Pero from this reaction alone, makikita natin yung difference niya. Ibig sabihin, we have 2 hydrogen molecules which has 4 atoms. Kasi diba, yung subscript is 2 times 2 na yung coefficient, so 4 atoms. In this molecule naman, we have 1 oxygen molecule, and it has 2 atoms rather. It has 2 atoms, and this molecule of water, these 2 molecules of water have 4 hydrogen atoms and 2 oxygen atoms. So, yun lang ang pinagkaiba ng molecules and atoms. So, paano itong mole method? Ganon ang mole method rather. So, paano yung relationship naman ng tatlong substance kanina? So, we have 3 substances, diba? We have the hydrogen, the oxygen, and water. In this balance equation, we have coefficient na 2, 1, and 2 respectively. This means that 2 moles of hydrogen react with 1 mole of oxygen to produce 2 mole of water. So, in doing stoichiometric calculation, let us start with identifying ratios. In this particular reaction, we can have 3 mole ratios. So, what are these 3 mole ratios? 2 mole of hydrogen is needed to react with 1 mole of oxygen. Makikita natin dun sa balance reaction natin. So, here, 2 mole of hydrogen per 1 mole of oxygen. Next, 2 mole of hydrogen is needed to produce 2 mole of water. And lastly, our last mole ratio is 1 mole of oxygen is needed to produce 2 mole of water. We just need to look at in our balance equation para malaman natin kung ano yung mga mole ratio. So, let's have an example. A sample of 4.8 moles of hydrogen reacts completely with oxygen to form water. Calculate the amount of water produced in moles. So, in this particular example, we are given 4.8 moles of hydrogen. And we are required to calculate the amount of water produced in moles. So, parang ano lang siya, parang one-step conversion lang. You will convert the 4.8 moles of hydrogen into moles of water. So, paano to? Ganito lang siya. Diba? We have our reaction kanina to produce water. So, this is our reaction. So, moles of water produced is equal to yung given natin 4.8 moles of hydrogen times yung ratio ng water to hydrogen. So yan, 2:2 kasi we need 2 moles of hydrogen to produce 2 moles of water, kaya 2/2. And then makakancel yung mole of hydrogen and mole of hydrogen. So we will be having mole of water na lang as our unit. So ayan, 4.8 mole of water. So ganyan lang, parang ano lang siya, parang conversion lang siya from one unit to another. Another example, suppose 10.7 gram of hydrogen reacts completely with oxygen to form water. How many grams of water will be formed? So in our previous example earlier, we are given moles of hydrogen, but this time we are given grams of hydrogen. So paano to? Paano ang gagawin natin? In this example, we cannot directly use the gram in stoichiometric calculation kasi 'di ba, the coefficient in a reaction is in terms of mole lahat. So the first thing that we will do is to convert the gram of hydrogen to mole of hydrogen, and then after na nakuha na natin yung mole of hydrogen, we will convert this to mole of water, and finally, we will use this mole of water to calculate the gram of water. So, ayan. So, moles, first we will calculate the mole of hydrogen. So, 10.7 gram of hydrogen yung given natin times 1 mole of hydrogen in our periodic table. Makikita natin na ang molecular weight ng hydrogen is 1. So since 2 atoms tong hydrogen natin dito, so 2 times 1 kaya 2 gram. Etong nandito 2 gram kasi yun yung molecular weight ng H2 natin. So, we can be able to get 5.35 mole of hydrogen. And then, using this 5.35 mole of hydrogen, we can be able to calculate the moles of water. So, 5.35 mole of water. So, ano ang ratio ng water to hydrogen? So, looking at in our balance reaction, itong nandito, 2 mole of hydrogen, yan, is needed to produce 2 mole of water. Kaya, 2:2 itong nandito natin. So, we can be able to get 5.35 mole of water. And then, lastly, we will use this 5.35 mole of water to calculate the gram of water. So, ayan, 5.35 mole of water times 18 gram of water all over 1 mole of water. Kasi 'di ba, ang molecular weight ng water is 18 gram. Kasi marunong naman siguro lahat tayong kumuha ng molecular weight, 'di ba? The molecular weight of oxygen is 16 plus the molecular weight of H2 is 2, so 18 gram. And then makukuha na natin ang gram, which is 96.3 gram H2O. So, ayan. Yan, ano lang siya, conversion lang from one unit to another, from one form to another. Ito naman. And for our last example, urea is used as fertilizer component in animal feed and in manufacture of polymers. How many hydrogen atoms are present in 25.6 gram of urea? So, I've mentioned a while ago na ang 1 mole of 1 mole contains exactly 6.022 times 10 raised to 23 elementary entities. So, magagamit natin yon in this example. So, here's the structural formula of urea. O, ito yung pag-solve natin ng molecular weight. Yung N natin dito, our N here, this should be 14. 2 times 14 gram per mole is 28 plus 4 times 1 is 4. So, 28 plus 1 is 32 plus 12 plus 16. So, ito ang bakit hindi ko nailagay dito? So, this is 60 gram per mole. And then, gagamitin natin tong molecular weight dito to compute the atoms, hydrogen atoms na nasa 25 gram urea natin. So, we are given 25.6 gram of urea. Ito yung given. Times, in 1 mole of urea, we have 60 gram of urea. So, ito yung na-calculate natin using this one. Times, in every mole of urea, may 4 mole of hydrogen tayo. Kasi dito, di ba, yung subscript natin na 2 times yung subscript natin dito ng H is 2. So, 2 times 2, kaya 4 mole of hydrogen. Times 1 mole of hydrogen. In every mole, we have 6.02 times 10 raised to 23 H atoms. So, ayan. So, this will be, makakancel yung mga unit. Cancel. So, may iwan lang ang atom. So, this is our final answer. So, madali pa lang itong first topic natin. Okay, so this is the summary of the steps in stoichiometric calculation. So, first, we need to ensure na balance yung equation natin. If we are given an equation, wag kayong directly stoic calculation kasi we need to ensure that we have a balanced equation, balanced chemical equation kasi we will be needing the stoichiometric coefficients. And then, using these stoichiometric coefficients, we will find the appropriate mole ratio. So, moles of desired substance all over moles of known substance. Ito yung mga minumultiply natin dun sa given natin. And then, if we have, if ang ating given is in terms of mass, we will convert it to moles muna. Moles of known substance. And then, kapag nakuha na natin yung moles, we will convert it to the moles of desired substance using our ratio. And then, finally, we will convert this moles of desired substance into mass of desired substance. So, depende lang yan kung ano yung nire-require ng problem sa atin. Next, we will proceed in the limiting and excess reactant. From the word itself, diba, very obvious na when we say limiting reactant limits the amount of product produced. So, eto yung unang nauubos. This is the reactant that runs out first. Yung yung maiiwan, the reagent leftover is called the excess reactant. So, we see when we react to two substances, it is essentially impossible to have them precisely the correct amount for both of them to react completely. Walang ganun, walang exact na kapag nag-react ka ng dalawang substance, exact amount lang yan. There will always be a limiting and there will always be an excess reactant. So, yung limiting reactant natin or yung limiting reagent natin, this is the one that runs out first, which make reaction further impossible. So, hindi na magpro-proceed yung reaction kasi naubos na nga yung isa. And then, the other reagent will then be said to be excess because there will be some leftovers. So, in order to tell which is the limiting, we have to see which quantity will limit the reaction stoichiometrically. and it won't be automatically the substance that is present in the lesser amount, kasi baka mamaya may mga given dun sa problem, and then makita natin na mas maliit yung given amount ng isa. This is the limiting reactant kasi mas mababa yung amount niya. So that's not always the case. For example, in making sandwiches, ito yung reaction natin. We need 2 breads plus 1 ham or 1 ham, 1 patty, ganyan, to make 1 sandwich. Let's say we have 7 ham. And this 7 ham can potentially make 7 sandwiches. Diba? Kasi isang palaman lang naman ang kailangan to make 1 sandwich. And we have 10 bread. 10 bread, in every sandwich, we need 2 breads. So, ibig sabihin, we can only make 5 because we need 2 per sandwich. So, even though there are more bread than ham, it is the bread that is the limiting reactant in this example. The bread will be used fully and leave ham in excess. So, kapag 5 sandwich lang yung magagawa natin, ibig sabihin may excess tayo na 2 ham. So, yun ang ibig sabihin ng limiting and excess reactant. So, yung limiting natin dito is yung bread, and yung excess natin is yung ham. May excess tayong 2. Let's take a look at a real reaction. So, ganito. Urea is produced this way. So, we need 2 moles of ammonia plus 1 mole of carbon dioxide to produce urea. If we start 10 gram of each reactant, which one limits the reaction? Ano kaya ang maglilimit sa reaction natin? Well, the first thing that we need to do is to convert the moles. Because, diba, sabi ko kanina, mass doesn't tell us anything. So, we convert both to moles using their respective molar masses. So, ayan. So, molar masses. Ayan. So, 10 gram of ammonia, i-convert muna natin siya sa moles niya using yung molar mass ng ammonia, di ba? Ang N is 14 and ang H natin is 3. So, 17 gram of ammonia and magkakaroon tayo ng 0.588 moles of ammonia. And then, the same thing dun sa carbon dioxide natin, 10 gram of carbon dioxide. So, per mole of carbon dioxide, we have 44 gram of carbon dioxide. Kasi C is 12 and O is 16 times 2, 32. So, ayan. So, 44. Kaya 44 gram yung carbon dioxide natin. And then, we can be able to get 0.227 moles of carbon dioxide. So, eto na ba? Enough na ba to para ma-determine natin kung saan dito ang limiting? No, hindi pa. We still need to use our stoichiometric coefficient kasi di ba hindi pa natin nagagamit. Kinonvert lang natin yung given mass. So, ayan. So, 0.588 moles, let's see to it kung ilan ang maproproduce natin na product using the mole of ammonia. So, 0.588 moles of ammonia. Ayan. 1 mole of urea. Kailangan natin ng 2 moles of tawag dito, ammonia. Kaya ito yung ratio natin. And ang maproproduce natin na urea is 0.294 moles. While kapag ang ginamit natin ay yung 0.227 moles, 1:1 lang naman ang ratio per mole of urea, we need 1 mole of carbon dioxide. So we see 1:1 lang yung ratio nila, so we can be able to calculate 0.227 mole of urea. So the moles, so we see na yung amount ng carbon dioxide na na-calculate natin is mas maliit compared dun sa amount ng NH3 na na-calculate natin. So, meaning to say, our limiting reactant in this reaction is the carbon dioxide. Diba? Kasi the carbon dioxide can produce as much, so that must be the limiting reactant. Ayan din. We can also calculate we can also see how much of the other reactant each could react with. So kapag nag-react yung 0.588 moles ng ammonia with the carbon dioxide, we can be able to calculate 0.294 moles of carbon dioxide, which we don't have kasi 'di ba ang mole lang ng carbon dioxide na na-calculate natin is 0.227. So if we will going to react the ammonia completely, hindi possible kasi kulang yung ammonia na gagamitin natin. So talagang yung carbon dioxide ang limiting natin. And then, next naman is 0.22, mali yung na-highlight ko. Ito pala. Ito pala dapat. 0.227 moles, 0.227 moles only ang carbon dioxide natin. And kapag ni-react natin completely yung NH3, hindi possible kasi kakailanganin natin ng 0.294 moles of carbon dioxide, which we don't have. The same thing with our carbon dioxide. Kung gusto nating i-compute kung ilan ang ammonia na magre-react kapag ni-react natin completely itong 0.227 carbon dioxide natin. So 0.227 carbon dioxide times 1 mole of carbon dioxide in every mole of ammonia. So, makikita natin na ang mako-compute natin is 0.454 moles of ammonia, which we do have kasi 0.588 moles of ammonia ang given sa atin. So, possible yon. So, really, the limiting is our carbon dioxide. Okay, next. Ayan. So, another real-life limitation of chemistry is that the amount of product we calculate that we should get is actually just the theoretical yield. Ibig sabihin, yung kino-compute natin ngayon, the stoichiometric calculation, yung mga nako-compute natin na product is just the theoretical yield. This is the amount of product we can expect if every molecule of the reactant will convert flawlessly into product. Ibig sabihin, perfect ang reaction natin, and there's no such thing as perfect. Ideal lang siya, pero in real life, hindi talaga siya nangyayari kasi walang 100% conversion. Walang 100% efficiency in real life. So, may tinatawag tayong actual yield. In reality, hindi talaga nangyayari ang theoretical yield, so we have the actual yield, which is the fraction of theoretical yield. Etong actual yield, this is our yield, or this is yung product natin that we can be able to have during experimental sa mga laboratory experimentation. Ito yung masosolve natin na ito yung kukuha natin na product during experimental laboratory. So, yon ang tinatawag natin na actual yield. And actual yield is always a fraction of the theoretical yield. And this fraction is tinatawag natin na percent yield. So, ayan, ito yung equation natin for the percent yield. Ito yung ratio ng actual yield natin to our theoretical yield. Let's say, for example, kanina, yung urea natin. Let's say, for example, na our calculated, let's say, for example lang our calculated urea na na-produce natin is 10 grams. Pero, upon experimentation, ginawa natin, for example, sa laboratory, and ang nakuha lang natin is 8.9 grams. So, ibig sabihin, 8.9 grams all over 10 grams times 100, ito yung percent yield natin, itong 89%. Percent yield is an important measure of the efficiency of a reaction. So, ibig sabihin, when we have high percent yield, ibig sabihin efficient or maganda yung reaction natin. Efficient siya, magandang gamitin yung reaction, or maganda yung process na ginawa natin in order to come up with the product. So, ayan, ang pagkakaiba ng theoretical yield, actual yield, and percent yield. Ulitin ko, theoretical yield, this is the calculated amount using the stoichiometric calculation. Actual yield, this is the yung actual product na may yield natin during laboratory experimentation. And percent yield is the ratio of the actual yield to theoretical yield. So, yun lang. Hanggang dun lang ang discussion natin for today. So, next meeting, I will be giving you more examples ng lesson natin ngayon about stoichiometry. Kasi medyo mahirap ang mag-video record kapag mag-isa lang, walang interaction with the student. So, yun lang muna ang mai-share ko for our today's discussion. So, have a good day, guys, and happy Sabbath. I'm going to church today. So, have a great day.